Hello, everyone, and welcome back. We have another great and very interesting presentation that is going to start now from Cecília and Alex from Facebook. Very quickly, both Alex and Cecília, they belong to Facebook's Data for Good team. And this team builds a privacy-protecting data sets to aid humanitarian response work for natural disasters and public health crises. Alex, in particular, is a research manager on this particular team. Cecília is part of EMEA, public policy manager in the same team. Both of them have an extended career in the social impact area. Alex has been part of an NGO called IREX that was working in countries like Ukraine, Namibia, and Washington, D.C. in the US. And he also served as a Peace Corps volunteer in Namibia for 2 to 3 years. And in terms of his background, he has a bachelor's in physics from University of Illinois and the same master from the same university. Cecília joined Facebook in 2016. As I said, she's part of the EMEA Public Policy Manager, but she was previously part of the Facebook's European Union Public Affairs Department, focusing on issues such as privacy, competition, AI, and cybersecurity. That being said, I wanted to welcome both to the stage, Cecília and Alex. Both have very diverse experience, so each one of them would have very different points to add, complementary ones. And we are very excited to hear you and all about your projects. Hi, Cecília.
Hi, thank you so much, Anna, and the organizers of the summit. I'm very glad to be here today and provide you with an overview of what the Data for Good team at Facebook does. I'm trying to share my presentation, which I don't seem to be able to do.
Otherwise, I can jump in. Just give me a second.
It would be great if you could do it. I can't share my presentation, unfortunately.
Just give me, I'll be able to share it. I can see, let me see. Okay, we have also Alex. Hi, Alex. Welcome. Can you hear us loud and clear?
Hi, everybody. Yeah, it's loud and clear from my side. The screen share looks like it's starting now.
I think, do you guys see the screen?
Yes, so now you just have to put it in full screen.
Do you see the presentation right now?
Yes.
Perfect.
It's showing the whole slide deck, not like the presenter view.
Okay, so let's try with this. Can you see the real presentation right now?
Perfect.
Looks good, yeah.
Perfect. Okay, great. So let's start again. I'm very glad to be here today and talk about what our team does. I will provide you with an overview of what we do, what are the products that we have developed so far, and what is our privacy approach. And then I will give the floor to Alex, who is gonna dive into some of the specific examples and data set we have. So first of all, the Facebook Data for Good team. What do we do? As Anna has said in her introduction, our goal is really to share our data in a privacy-preserving way with NGOs and academia in order for them to help them actually to address some of the biggest humanitarian issues in the world. So everything started, the team actually was born in 2016. following the observation that some humanitarian organizations had actually an information gap when taking care of disaster response, for instance. And at Facebook, we realized that actually we had a lot of information that could have been helpful for them to do their activity in the disaster response area. So everything started from then, and then it expanded in other areas, and actually addressing additional issues. And something that has been a big focus of the activity in the team was COVID-19 in the last couple of months. So we now cooperate with nearly 400 organizations in over 60 countries on all sorts of issues: disaster response, COVID prevention, economic recovery, and so on and so forth. I wanted to provide you now with a very kind of general overview of our products, and Alex is going to dive more specifically into the Maps for Good. So there are three main families of products that we have. The first one, Maps for Good, is basically maps that we developed using or not Facebook data. Something we did, for instance, as I was mentioning before, in the area of COVID-19 is developing movement maps and disease prevention maps to see how people were moving across different areas to better inform policymakers and health organizations on how to reassess or target specific health protection measures. A second family of products is called Surveys for Good. And what we do is that we deploy surveys to Facebook users in order to inform policymakers on specific issues. So once again, we did a few for COVID to try and understand people's attitude and behaviors and knowledge on COVID-19, and therefore to better inform policymakers on how to target COVID measures based on evidence and how people were addressing that. And then a third area is called Insights for Impact, and it pretty much consists on monitoring public posts on Facebook to help increasing the reach on some specific public awareness campaigns. So we worked with UNICEF on vaccination campaigns using data coming from Insights for Impact. So those are the three main family of products. But I also wanted to talk about the way we share our data with our partners or publicly. So as you see, we have a category of data that are publicly available. So we share them with whomever want to access them, and those would be the data that are more aggregated and less privacy sensitive in a way. So those are really available to anyone who wants to access them. We do have other data sets that are more granular, and therefore they require a data licensing agreement that our partners sign in order for those data to be used by specific organizations for specific uses. Alex can take that a little bit more in detail later if there are questions. So, and before we go into the specific data set, I also wanted to present what is our approach on privacy. And this is a very important, something that is very dear to me personally, because I actually joined very recently the Data for Good team, and I was before still at Facebook working on privacy. So it's important to really bear in mind that we do think that we can share data with our partners in a privacy protecting way, which is really at the core of the what Facebook does and what Facebook cares about. So our privacy protection approach is actually shared in a peer-reviewed journal for other actors to see that and to provide us with feedback, and also to maybe get inspiration if other entities want to share data in a privacy protected way. As I said, there are a number of themes. First of all, access control. As I said before, there are data sets that we share only under data licensing agreement, because they are specific, they are particularly sensitive from a privacy perspective, and they are more granular. There is also an element of user control. So I was talking about surveys before. Surveys are absolutely opt-in. So a Facebook user can decide to take them or not, and it needs to consent for its responses to being used for research. And same thing for maps. Some of the maps are developed using Facebook location history, but this feature is opt-in. So as a Facebook user needs to concretely go and enable location history use if he wants those data to be used then to create maps. And then there are a number of techniques that we have developed in order to protect users' privacy. So the identification that pretty much consists in avoiding that to associate the identity of a person to a specific information. Aggregation, so we draw insights from data that are aggregated, for instance, from geographic data that are aggregated and not really related to a specific user, or adding random noise to a data set. So adding a small amount of values of variation to the data set in order to make true counts impossible. Once again, this is not exhaustive. And if you have additional questions, we can see them later during the Q&A. I think I can now give the floor to Alex for him to dive into the use cases. So please, Alex.
Thanks, Cecilia. So some of you may have already gone to the website that you saw on Cecilia's slides, dataforgood.fb.com. You may have noticed that there's a wide range of data sets available. So I'm going to just cover two that we thought would be particularly of interest to the audience for today's event. And we specifically chose them to not be so focused entirely on COVID, because we know there's been previous events that have focused on this crisis type, and maybe just a change of pace. But we welcome questions about their applications to COVID, but don't think that we avoided it specifically. We're happy to discuss it. So the first, I like to start not by describing a data set, a tool, or a solution, but instead describing the problem that we're trying to help humanitarian response organizations solve. And the first question is very common across a wide range of humanitarian response work, which is, where do people live? We might be trying to determine those that might be at risk for a natural disaster, those that might be in the path of a hurricane, like Hurricane Delta, which just hit the Gulf Coast in the US over the weekend. Or we might be doing things like distributing vaccines, like shown here for Ebola. How many treatments should we send to village A versus village B? And in many parts of the world, this question is very difficult to answer. Perhaps a survey hasn't been done in a long time. Perhaps to protect privacy, it's been very aggregated. So we think we have built a data set which has proven very useful to answer this question. And I'll explain how we built it. Next slide, please. So our population density estimates do two sources of data. We combine census projections, so estimating what a census result would be if it took place this year. This is developed by Columbia University's CSIN group. And this would show like census and demographic counts of people across a census block or a different administrative unit. To make our population density projections more accurate, instead of distributing population counts over census blocks, we instead distribute them over places where we have looked at satellite imagery and detected buildings, since people almost always tend to live where there are structures. Next slide. As I mentioned, there's the two sources of data. So we've collaborated with Columbia University on those census projections for many years now. And this means that almost a fundamental privacy protection built into the data set is that we're not making use of Facebook data whatsoever. We're just using kind of our spatial computing know-how and our processing power to analyze very, very large imagery data sets and also very, very complex population estimates. So this is like our first choice for privacy protection is let's only use data that's publicly available. And this is what this product has done. Next slide. So here's a village in northeast Namibia that will show you how we build the data set, our population density estimates. So we have an overhead image taken from space that we purchased from Maxar. And what we want to do is train a computer vision algorithm to identify the 30 meter by 30 meter grid cells that contain a building. And this is essentially the same thing that you do when you sit in the window seat of an airplane. You look outside and you say, oh, that's a road, that's a building, that's water, that's a tree. We're kind of training the algorithm to do that same thing, but it's only looking for buildings. And it produces then for each 30 meter by 30 meter tile on Earth, what its expected confidence is that there is a building present in there. So let's see the results of training this algorithm on this particular village. So you can see here, all of the purple tiles are those 30 meter by 30 meter cells where our machine vision algorithm is very confident that it sees a building. And it is performing fairly well. There's very few false positives. There are some buildings that are missed. This particular village, there was very few concrete structures, permanent. Most of the dwellings are built out of traditional materials, and it is important that we train our models on a sub-regional level because buildings look very different around the world, even when you look from high up in space. So to summarize, our algorithm is very, very good at identifying where there are no people. That is kind of the secret sauce on this data set approach, or this approach to population density mapping, compared to other methods. So we are very good at knowing where no one lives. Next slide. So then, instead of doing this for just one village in Namibia, let's do it for the entire globe. And that is what we've done. So this is a very computationally intensive exercise. So there's a lot of kind of boring things on the back end where we've had to optimize our infrastructure to compute these things in a short period of time. The data set, since it doesn't use any Facebook user data, means that we can release fully publicly the results of our population density estimates, and we can carry forward the demographic disaggregations that are available in the census counts. So we're not doing any household modeling here. We're simply breaking up like census blocks into smaller tile estimates. And so you'll get values like in this 30 meter tile, we estimate that there's 0.2 people over the age of 60. Obviously, human beings come in whole numbers. Our data set is just an estimation, a distribution of census counts. We're not trying to predict household level composition with this type of work. Next slide. So you can see now as we begin to take away that satellite imagery layer and look just at the population density estimates, we're seeing the granularity at the coarseness of the data set globally but we can begin to see the pockets of population forming in the usual areas. Next slide. And now we've removed the satellite base image entirely, and this is the most accurate map of the world that we're able to produce, just looking at the human population. Next slide. So I want to call out two recent applications that have made use of this data. There's a very powerful research publication conducted by the University of Washington's Institute for Health Metrics and Evaluation, mainly from scientists who work on the Malaria Atlas project, who compared different methods of population density estimations with a kind of gold standard population density survey that took place on Bioko Island. And their findings are very informative to understand which data sets are most accurate in very dense urban areas versus ones that are most accurate in rural areas. Our data sets are found to be the most accurate in the very rural areas because of this consequence of being very much able to tell where people don't live. And these population density base layers were used by German scientists at a Max Planck Institute as a base layer for predicting where COVID-19 case counts might increase since the disease is transmitted between people. And they can run many different scenarios based on different estimations of human contact using our population density maps as a base layer. And that's what you see on the right. Next slide. Since the data sets are derived without using Facebook user data, this means that they have a fully public license, which means you can incorporate them into your own applications, like Ohio State University researchers did here. They use our population density maps alongside data on displacement, vaccination availability points, points of entry on national borders in Eastern DRC, and reports of violence. So their application, this dashboard that they kind of built and made available, ours is one piece, and we really welcome people to have, to integrate this data with other sources of truth. We don't try and portray our data that being the be all and end all. We see it as a piece of the puzzle that we hope can inform many different types of applications. Next slide. So now I'm going to switch gears and talk about a different geospatial data set that we make available called the Climate Conversations Map. Next slide. So this data set does make use of Facebook user data. We're looking at people's public posts that share URLs on the platform. And we look at those on spatial aggregations, like by country, or by like administrative boundary level 2, like states or counties. And we look at trends over time, like days and weeks and months. But because the source of the data comes from Facebook users, this means we can only release the data sets under the controlled data license agreement that Cecília mentioned. If you're interested in this or our other controlled access data sets, you can see the next steps to request access on our website, dataforgood.fb.com. The Climate Conversation Map, it looks at all of the URLs shared on Facebook. And first, it classifies those that are related to climate change based on the URL text or the preview URL preview that's generated for the URL. And if it matches any of our different keywords or our algorithm's ability to detect climate change as a topic in the article in 27 different languages, then we flag those and count them. And when we study the volume of those, and our partners can study the volume of those URLs, the types of reactions and sharing behavior that people have, and study that over time and compare between different countries. So this has been very useful. Next slide. To study different trends as we see climate change impact and make more pronounced the effects of natural disasters around the world. So in wildfire season here in the US, do we see an increase in the amounts of URLs related to climate change? compared to other seasons? And how does that compare to wildfire season in Australia, both of which have been very pronounced crisis events in the past? So we're eager for more researchers and NGOs to dive into these data sets and find new use cases which we've not even thought of. And we look forward to your questions.
Thank you, Alex. Thank you, Cecília. And actually, it's interesting that you just mentioned the data sets, because most of the questions that people have been asking about is exactly on that topic. One of them, I think you already answered in a different way, but Katarina is asking if you could give an example of a project where your data sets really made a difference. Something that comes to your mind, or something that personally to you had more significance.
Yeah, the most significant recent one, which I'm proud of, is about 3 weeks ago, we released a public version of this data set called the Social Connectedness Index. And what this data set is that for any 2 places in the globe, let's say like county level, so San Francisco County and Cook County, what is the relative probability or strength of aggregated friendship ties of all Facebook users between them? So it's, instead of thinking of places separated by distance, we can think of them as separated or connected by the strength of the friendship network on Facebook. Researchers at MIT studied the effect of this social connectedness between regions and compared it to the spread of COVID and people's likelihood of preventative health behaviors, such as mask wearing, social distancing. And they found it to have a larger effect than distance, weather, or other phenomenology. And this makes intuitive sense. People tend to maybe copy the actions or take things seriously that their friends do. And the research thus is very powerful in exploring that social science dynamic to a public health response. I'll drop the link to this publication for others to read and learn more about. That Social Connectedness Index dataset, even though it comes from Facebook user data, we spent a lot of effort applying a very transparent differential privacy framework to the dataset to minimize re-identification risk of users, and thus we're able to release it fully publicly on the UN's Humanitarian Data Exchange.
That use case is really interesting. So basically, maybe that started with the question, what is the variable that influences the most? In that case, we could talk about COVID, but what is the variable that influences the most how often people talk, or the relationships? And it's interesting that the distance is not the main criteria, which is good because we are in a globalized world. So if that is the criteria, we would not progress very fast. Okay, so we have other interesting questions. Sorry. Do you perform internal projects with those data sets, or your team is more focused on creating and sharing them? So are the applications internal or external after the creation of the data set? Is the use case also implemented by Facebook, or is it that you provide the data to third parties and then they are the ones implementing those use cases?
It is definitely the latter. So we are kind of trying to fill the data gaps of partners. Sometimes we get lucky and we find something that was built internally for a business use case that fits that gap perfectly. But almost, I'd say 90% of the time, we are kind of trying to better understand, like my background comes from humanitarian response, but this network of 400 institutions and the thousands of users that then get access through those institutions, it is listening to their data gaps and then building towards those that the program is focused on. Sometimes we get lucky that there was a Facebook effort that produced the data set and the tool can be repurposed. But almost always there's at least a little bit of tweaking on the privacy side to make sure it meets our rigorous standards.
Exactly. And I also could complement that based on my experience talking with NGOs, a lot of times they actually want to use open data, but they are not able to find reliable open data sources. So I completely understand the problem of, or the urgency of creating reliable data sources, so that then third parties such as NGOs, foundations, and government could later use it. There is now one question about the team, so your team in Facebook. And the question is, how big is your team? And I would extend this question to how big and what type of profiles exist in your team.
I can answer again, but Cecília can also add her experience. The team is very new. Well, Facebook as a company is pretty new. We're 15 years old. But Data for Good really became a formalized thing as like a name and a team in 2017. We've grown very rapidly. So there's around 6 of us that are fully dedicated to this effort. And that has grown a lot in 2020. But then we work with data scientists, engineers, product managers, partnership managers from across the company. And so we kind of say that the family of Data for Good, it's around 50 people. Not all of them are doing this, as 100% of their job. But it's a strong growth trajectory within the company. So hopefully that number increases. My background is more on the technical side. So working on privacy protections and the statistical analysis within a data set, applying kind of adversarial techniques to see if we can validate the privacy protections that we calculate theoretically. That's really, we kind of have almost a huge group of different backgrounds. Cecília, do you want to add your expertise as well?
Yeah, maybe, I mean, you were very exhaustive, Alex. I can chime in, just bring in my own experience. And I must say, I am pretty new to the team. I joined the team just over 1 month ago. So it's really, really new. But on my side, I do not have a technical background. So my role is really to make sure that we that first of all, we take into account in developing our products and in releasing new data sets of the public policy goals that organizations are submitted to. So are we focusing on the right priorities? Are we being useful to what happens in the world? Are we being useful to our own constituency, to our partners? And so my profile is very much partnership and public policy on that perspective. So I would be on a spectrum of technical profile and non-technical profile, be more towards the non-technical profile.
This question is particularly interesting because we would have people that are trying to onboard in this journey. Some of them are more technical, some of them have some technical knowledge, but they are more expert in the strategy, in creating the partnerships or the connection. So it's interesting to see that this is an example of a team that has people from different backgrounds with different experiences previous to this team. So I think this question is pretty interesting.
Yeah, I would say that this is very intentional. So it would be very easy for a tech company like Facebook to just like cause an avalanche or like a fire hose of data. And this often causes more problems than it solves for humanitarian organizations, especially in crisis response, where there isn't time to consider or study in depth a new data set or a change to one that was trusted. So we need to make sure we're balanced. One, focus on the problems that we're trying to solve and be intentional about the data sets that are available for those. And then the strengths and weaknesses of the data set.